Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on a question from a past exam paper, November 2018, for Mathematics Grade 11. And we're focusing on the topic of exponents and surds. Let's start. Question 2 says 2.1, simplify fully without using a calculator. And this is the question. All right, now when you have a question like this, step number one is you break up your exponents into factors with different powers. So that means we take 2 to the power of x, we break that up, that becomes 2 to the power of x times 2 to the power of negative 3 minus 3 times 2 to the power of x times 2 to the power of 1. That's how we break that up. Now that is all over. Alright, that is all over. Same story at the bottom. We also break that into its powers. That's what we get. Now notice that you have a common factor, and this is the common factor. I'm going to put a ring around the common factor. Here is the first common factor. Let's make it red so you can see exactly what. Here is another 2 to the power of x. That is our common factor, another 2 to the power of x. So what you do is you keep this in mind that it is a common factor. So what we do now is we factorize by taking out a common factor. So we factorize, we go 2 to the power of x. We take out that common factor and that leaves us with, and the first one, it will be 2 to the minus 3, 2 to the negative 3 minus 3 times 2 to the power of 1, or just simply 2, all over, let's change the color, all over, there will be all over 2 to the power of x times 2 to the power of negative 2. Excuse me there. So now we cancel out the 2 to the power of x. They cancel out, common factor, you cancel it out, and that leaves you with 2 to the power of negative 3 minus 3 times 2 all over 2 to the power of negative 3. 2 to the power of negative 2. Now what you do is you manipulate this. It will be very easy to manipulate, and that gives us, okay, so that gives us 1 over 2 to the power of 3. That's how we leave that in a positive, minus 6, or you can write that as 6 over 1, all over 2 to the power of negative 2 can be written as 1 to the power of 2 to the 1 over 2 to the power of 2. So that's 1 over 8 minus 6. So that is 1 over 8. 1 over 8 minus 6, or 6 over 1 if you prefer, all over 1 over 4. 1 over 4. If you avoid using a calculator, something they said we shouldn't do, now we add these fractions. How do we add the fractions? So we go 1 over 8 minus 6 over 1. Okay, the LCD over here is 8 times 1, which is 8. Alright, so what we do is we have everything over 8, and then to find the numerators, we must multiply both fractions by 8. This one cancels out, so it leaves us with 1 minus 6 times 6 over 1 times 8. 6 times 8 gives us, take out a calculator, 6 times 8 will give us, 6 times 8 will give us 48. That is the answer that we get. So that will be 48. So that will be 1 minus 48. Okay, so that will be 1 minus 48 all over 8 over 1 over 4. And that gives us 1 minus 48, that is negative 47 over 8 all over 1 over 4. Now When we divide a common fraction by another common fraction, what we do is we end up with the bottom fraction flipped upside down. And this is what happens now. 4 goes into 4 once and into 8 twice. That's the common factor that we divide by, and that leaves us with negative 47 over 2, and that is your final answer. You can leave it in this form or you can leave it in a decimal form, whichever way, that's fine. Next question goes 2.2, solve for x. 2.2.1, that is the question. So it's 2 minus 16x to the power of negative 3 over 2, just in case you did not see that clearly. And this is the question. So what we do here is we simply take this to the right hand side so it becomes positive. X to the power of minus 3 over 2. And therefore now we can divide both sides by 16 to get rid of the coefficient of that. So that gives us 1 over 8 equals to x to the power of minus 3 over 2. Now we raise both to the power of 1 over 8 all to the power of the reciprocal, the positive reciprocal of this. That will be negative 2 over 3. So that's what we raise it, negative 2 over 3 on both sides. Alright, so that leaves us with, notice that over here the 3's cancel out, the 2's cancels out, and the negatives multiply out to a positive. So that leaves us with x to the power of 1, which is just x. Now that leaves us also with 1 over 8 to the power of negative 2 over 3. But remember that 1 over 8 can also be written as 2 to the power of 3. 1 over 2 to the power of 3, leaving us with this answer. So therefore that becomes, okay, take this 2 to the power of 3 to the top, that becomes 2 to the power of negative 3, and that is what we have. Now you raise this power to another power, so that leaves us with, okay, notice that the 3's cancel out and the negatives also leave us with a positive, meaning that therefore 2 to the positive 2 equals to x, meaning that x equals to 4. Just to make sure you've got the correct answer, let's check. Let's check the answer, and this is how you check. Check x equals to 4. On the left hand side, this is what we do. We go substitute 4 where there is x. So that will be 2 minus 16 in bracket 4 to the power of negative 3 over 2. So now what we do is we manipulate this. We employ our algebraic gymnastics. So that will be 2 to the power of 2 raised to the power of negative 2. 3 over 2. The 2's cancel out, and that leaves us with 2 to the power of negative 3. So that is 2 minus 16, 2 to the power of negative 3. But also remember that 16 can also be written as 2 to the power of 4. So that is times 2 to the power of negative 3. When we multiply powers of the same base, we add the exponent. So that will be 2 to the power of 4 minus 3, which leaves us with 2 minus 2 to the power of 1, which is 2 minus 2, and that is 0. So therefore, which is equals to the right hand side. It's equal to the right hand side. Therefore, x equals to 4 is the solution. And that's how you check. Is the solution. Next question, 2.2.2. There we go. 4 to the power of x plus 8 equals to 9 times 2 to the power of x. This is the quadratic equation, exponential quadratic equation. You may not see it now, but you will see as we simplify that. So step number one, you take everything to the left hand side. 4 to the power of x plus 8 minus 9 times 2 to the power of x equals to 0. Like I said, this is a quadratic exponential equation, but because you don't see that now, so what you do is you express 4 as a power with the base 2, so that is 2 to the power of 2 all to the power of x plus 8 minus 9 times 2 to the power of x equals to 0. Therefore, 2 to the power of 2x minus 9 to the power of 2x plus 8. Notice that all I did was rearrange this into standard format. I did not change anything at all. All I did was move the numbers around, the terms around, I mean. Now, notice that if we let k, if you don't have a problem solving it exactly the way it is, notice that 2 to the power of 2x is the square of 2 to the power of x. So if k equals to 2 to the power of x, therefore k squared becomes 2 to the power of x all squared, which leaves us with 2 to the power of 2x. Therefore, and so now we replace the 2 to the power of x by k, so that becomes k squared minus 9 times k plus 8. Now you can see this is a much easier quadratic equation to deal with and even factorize. Okay, so that will be k and k. Now the factors of 8 are 8 and 1, 4 and 2. The combination of factors that gives us 9 when we add is 8 and 1. And because this is a negative, that means we'll need, positive, we'll need negative and negative. When we add them together, they'll give you a minus. And when you multiply them together, they'll give you a positive. So that is the correct answer. Never skip this step, because that's where a lot of people make those silly mistakes. Therefore, k equals to 1 or k equals to 8. Now what we do is we substitute k back into 2 to the power of x, so that is 2 to the power of x equals to 1 or 2 to the power of x equals to 8. Now what you do is you express the right hand sides as powers of the base 2. So that is 2 to the power of x equals to 2 to the power of 0, because 1 can be written as a power to 0 with of any base, with the number base as any number, and that becomes 2 to the power of 3. Now that we've got powers of the same base equal, then now we can now equate the exponent. X equals to 0 or x equals to the other side, that is 3. You can check, just check. Always check, because just because you get the answer or the doesn't mean it's the solution. Check x equals to 0. We're gonna check x equals to 0 on the left hand side and x equals to 3 on the right hand side. Okay, let's do that. Okay, and then on the right hand side, that will be x equals to 3. Alright, let's start with x equals to 0. So we go to the left hand side. We go left hand side, we substitute that on the back to the original equation, equals to, so where there is x, we put 0, so that will be 4 to the power of 0 plus 8. That is, anything to the power of 0 is 1, so that will be 1 plus 8, which gives us 9. On the right hand side, same story. On the right hand side, where there is x, we put 0, so that will be 9 times 2 to the power of 0. Anything to the power of 0 is 1, so that gives us 9. Therefore, the left hand side equals to the right hand side, meaning that therefore x equals to 0 is a solution. Is a solution. We're not done. Let's check the other one. Alright, so x equals to 3, same story. Left hand side equals to, wherever there is x, we put 3 on the left hand side. That will be 4 to the power of 3 plus 8 on the left hand side, and that gives us 64 plus 8 And 64 plus 8, let's go. 64 plus 8 gives us 72. So that will be 72. Let's check the right hand side. The right hand side will be equals to 9 times 2 to the power of 3. 9 times 2 to the power of 3, which is 9 times 8. And 9 times 8 is, let's go, 9 times 8 is 72 as well. Therefore, the left hand side equals to the right hand side, meaning that therefore x equals to 3 is also a solution. Meaning that our final answer is that therefore x equals to 0 or x equals to 3 is the solution. And that's how you answer this question. In some papers, they do give you marks for checking and giving the final answer that is correct for both solutions. Alright, next question. This is 2.2.3. Let's go back to the original question paper so you can see what it looks like. Now it says solve for x. The xth root of 9 equals to 243. Alright, remember that the nth root, if you have the nth root of a and you raise that all to the power of n, basically you're just taking off the radical sign or the square root sign, as many people know it as. So what we will do is the same story. We will raise everything to the power of x to get rid of the radical. And that, but what you do to the left hand side, you must also do to the right hand side. Okay, on the left hand side, they all cancel out the radical. That leaves us with 9. And this becomes 243. If you're not sure how to convert numbers back to exponential format, so you go 243, sorry, 243, 243, or is it 342? 243 equals 2, and then you go shift and then press the fact button. It will give you the exponential form of that number, so that is 3 to the power of 5 in this case. So we have 3 to the power of 5. Let's take it back. 3 to the power of 5, all to the power of x. Now meaning that, okay, let's express 9 as a power. That is 3 squared equals to 3 to the power of 5x. Alright, we're raising a power to another power. You multiply the exponent. Now that we've got powers of the same base equal, all we'll do is we equate the exponent. Divide both sides by 5 to get rid of the coefficient of x. So they cancel out over here. And that leaves you with 2 over 5 equals to x. Check it. Always check. Let's check this. So we're checking x equals to 2 over 5. 2 over 5. Alright, on the left hand side, that's what we have. The left hand side equals to the 2 over 5th root, okay, of 9. That is equal to 9 to the power of 1 over 2 over 5. That's what it also means, which is supposed to, alright, 9 to the power of 1 over 1 times 2 over 5. That is 1 over 1 multiplied by 5 over 2. You flip it upside down. So that leaves us with 9 all to the power of 5 over 2, which is equals to 3 squared all to the power of 5 over 2. which is then 3 to the power of 2 times 5 over 2. The 2's cancel out, which is 3 to the power of 5, and that is equals to 3 to the power of 5. That is equals to 243. 243, which is equals to the right hand side. Therefore, x equals to 2 over 5 is the solution. And that's how you check that. And now for the last question. Let's go back to the original paper. Simplify fully and you've got the square root of the difference of two squares and all of that. Okay, so let's go. Now this can be written as the square root of the difference of two squares. So that is p plus q and p minus q multiplied together times p plus q in bracket p plus q all to the power of 5 over 2 all over p minus q all to the power of a half. P minus q all to the power of a half. Notice that this can also be written as p to the plus q all to the power of a half times p minus q all to the power of a half times p plus q all to the power of 5 over 2. This is the exponential expression of the surd. Converting that into exponential form, p minus q to the power of a half. Now, p minus q to the power of a half has a duplicate, so we have a common factor, we're taking it out. And that leaves us with p plus 1 all q. And then p plus q all to the power of 1 over 2 times p plus q over, times 5 over 2 there. Alright, now when we multiply powers over the same base, these are the same base, p plus q and p plus q. When we multiply powers of the same base, we must what? Add the exponent. So that will be in bracket p plus q 1 over 2 plus 5 over 2. 1 over 2 plus 5 over 2 equals to 6 over 2. So that will be p plus q to the power of 6 over 2. And 6 over 2 equals to 3. So that leaves us with, in bracket, p plus q all to the power of 3. And that is your answer. We've come to the